I would now like to introduce Ed Yu, who's a research lead at StrongSalt, for a keynote entitled StrongSalt, Data Privacy on Blockchain. Ed.
Thank you. So I'm going to start my talk with a story. Once upon a time, there was a guy. Does anybody know who he is? His name is actually Vint Cerf. He's considered the father of internet. The reason, if you're technical, you should know that he was a co-inventor of TCP. He actually said something earlier. I'm not going to read it over. You can read it. Basically, the idea is that he believes the internet was designed before security became a concern. So if you talk about data security, you talk about data privacy, a lot of problems actually stem from the fact that TCP originally was designed without security in mind. So if you actually can figure out what I'm going to talk about, this is actually what I'm going to talk about mostly. If you figure out the number, figure out what the picture is about, you can probably just take an 8-minute break, come back later, because this is what I'm going to talk about. So first of all, I'm going to talk about the picture. If you look at it, it's actually a thumb drive. What I'm going to say to you right now is that the best technology in the world, talk about cloud computing, talk about cloud storage, talk about blockchain. Nothing beats the security and privacy of this thing yet. Because if you think about what happens with your thumb drive, it's yours completely. You can do whatever you want with it. It's never shared unless you share it explicitly. And literally, if you turn off the network, this is yours. Once again, think about this. This is yours. If you put anything, share anything on the internet, it's going to be there forever. Even if it's not, somebody else is going to hack to it. The story, how people say there's no cloud, it's only someone else's computer. That's true even in the blockchain world. Really, nothing beats the security and privacy of this. But, so those are what I consider the biggest problems of cloud, right? And those are problems that we're trying to solve. But those are 5 problems currently existing in any cloud you use. It doesn't matter which cloud you use. It doesn't matter how secure they say they are. None of them can solve any or all of those problems. The biggest problem is that if you use cloud, any kind of clouds, someone else can see your stuff. It doesn't matter whether they are hackers. It doesn't matter whether they are actually somebody that you trust, whether it's somebody that you say, hey, but government can subpoena your stuff without telling you about it. There's gag order. They can say, hey, we never seen your stuff, but they actually have. Or they can have hackers access anything you want. So what does that mean? That means we want to solve that. How do we solve it? Actually, we solve it using different primitives for cryptography. What do? We use something called searchable encryption. Earlier, you heard about FHE. Fully homomorphic encryption is actually one way of searchable encryption. Searchable encryption encompasses a lot of different ways of doing this. We actually use a different way. However, searchable encryption alone allows you to encrypt and operate on the data without decrypting the data first. So that's actually very useful for a lot of things. We also, of course, this is a blockchain conference. We're going to talk about blockchain. Blockchain is also very useful for solving some of the 5 problems. And there's something called private information retrieval. What's interesting about PIR is that only until recently it has been what they call practical but slow. Actually, everything you hear about generally in cryptography is that it sounds absolutely great, except it's very slow. And when humans does not have patience for anything that's slow. But if you combine all 3 things together, you can actually have something that works really well. This is what we do. In StrongSalt, we actually combine all those things we just mentioned earlier into something that looks like this. The whole point of this is to tell you that sometimes security, you have to start from the bottom. You can't say, I'm going to have security and build an application layer on top of TCP, or cannot have something that says, I'm going to do something that's very secure or private, but then you use something that's off the shelf. If you want real security, you have to build things from scratch. So now I'm going to go back to the earlier picture and talk about the number. Why does the number matter? The number earlier, if you actually have taken high school physics, you probably know that number is the speed of light. So I'm going to use the example of a plane. The reason why is actually I'm part of the Stanford Flying Club, so actually I love flying my planes. So what you do with planes is that if you think about how a network works, network gets faster every day, right? You have 3G, you have 4G, now you have 5G, eventually it's going to have 6G, 7G, 8G, or if Apple gets away, XG. And it gets faster, but it only gets faster in what they call bandwidth. It does not get faster. There's one thing that never gets faster, which is how far to go from A to B. The reason why is that the speed of light is limited. So the equation you see there, that's basically how far is from China to US divided by how fast speed of light travels. It's about 40 milliseconds for one-way traffic. Think of this. Any network that has to go through China to US, which is not even across the whole globe, it's 40 milliseconds. And as we all know, human beings consider anything slower than 250 milliseconds to be slow. In other words, latency is something that can never be solved unless we break the speed of light. Or can we? Actually, I believe there is a way. So if you ever heard about QUIC, it's actually a UDP-based protocol, which actually, the main point of this is trying to say that if you continue on TCP, there's going to be latency issues. TCP is great for many, many things. But there are certain things, if you want to build something from ground up, we believe UDP is actually the way to go. So we actually are building our blockchain based on UDP. So the whole point of this, so let's go back to earlier, right, about the thumb drive. The whole point of this is that if we would talk about data privacy, the easiest way to think about data privacy is think about taking a picture of yourself. Think about taking a nude picture of yourself. Where are you going to put it? Think about where you're going to put it to make sure that no one else will ever have access to it unless you wanted to give it to somebody or unless you want to see yourself. So what we want to do is to make cloud computing so private using all different technologies to make it so that it's actually more private than your thumb drive, because there's several things about thumb drive that still is actually, there are problems with thumb drive. There's a reason why we use more cloud service now than thumb drive, right? Because thumb drives you can break. It can be, your data can be lost. You can lose your thumb drive. Somebody can steal your thumb drive. It might be corrupted. So we want to use technology. We want to use cryptography to solve all those problems so that cloud computing can be actually much more secure than it is. And of course, we want to use decentralized, because if you don't have decentralized, one company will always hold your data to hostage. So that's our goal. This is my email address. You can also reach me at ed@strongsalt.com. What we want to do is actually to basically, we want to build the next version of a fast, decentralized private information network, which actually uses cryptography from the ground up. And we're hiring people. So we're looking for people basically, if you like programming languages, if you like anything that has to do with security, privacy, encryption, even if you don't know what it is, we can always teach you. The point of it is that we are looking for smart people who actually who wants to program, because we're looking for programmers who love programming for the sake of programming, not just because it makes money. Of course, you want to make money, but we want people who actually enjoys it. If you like Haskell, if you like pure script, this is the place to go. And I think I'm done. And I'm pretty fast, actually. Thank you.